Welcome to today's explainer. If you've ever felt like artificial intelligence is just this exclusive luxury locked away in some massive corporate data center far, far away, well, get ready to change your perspective. Today, we're looking at something incredibly empowering. We are going to completely demystify the process of building your very own powerful and totally cost-effective personal AI system right in your own home. We're literally taking the power back and putting it right on your desk.
Okay, let's dive into this. Here's our builder's blueprint for today. We'll be covering building home AI, core hardware and config, parts and electricity costs, Llama and software setup, and finally, NAS integration in the future.
Right off the bat, we really have to ask the big question, right? Why go through all the effort of building a local AI when cloud services like ChatGPT or Claude are already out there? Well, it really boils down to three things: ultimate control, absolute privacy, and long-term cost benefits. Think about it. When you run a local AI, your data never ever leaves your house. Actually, scratch that. You don't even need an internet connection to run it. It basically becomes this ultimate digital vault for your sensitive financial documents, personal journals, or proprietary business data. Plus, no more monthly subscription fees forever. You actually own the intelligence.
Section 1. Building Home AI. Let's strip away the jargon and look at the physical foundation. So, a lot of people think building an AI machine is exactly like building a high-end gaming PC, but actually a pragmatic local AI build relies entirely on what the source material calls the holy trinity of local AI hardware. First up is VRAM, or video RAM. This dictates exactly how large and smart of an AI model you can actually run. Second is System RAM. That handles the context, like the massive PDFs or personal knowledge bases you want the AI to read. And third is stable storage for swapping those huge models really quickly. So if you're putting together a hardware compatibility checklist, here's a pro tip for you. Do not worry about flashy RGB lighting or dropping cash on a top-tier gaming processor. Focus purely on whether your motherboard has the PCIe lanes to handle the GPU and that it has plenty of room to expand your system RAM later on.
Moving on to Section 2, core hardware and config. Let's look at hitting the sweet spot for a stable, practical daily driver.
When analyzing the best hardware config for an entry-level machine, there is an absolute sweet spot: 16 gigabytes of VRAM paired with 64 gigabytes of system memory. What really stood out in the source analysis is the heavy recommendation for the RTX 4060 Ti 16 GB version. Right now, it is hands down the most cost-effective way to hit that 16 gigabyte magic number. You need that to run highly capable, reasonably sized AI models without the system just crashing on you. Paired with 64 gigs of system RAM, this optimal hardware configuration will effortlessly chew through your personal knowledge bases and handle complex document analysis.
Breaking down your options into three distinct tiers offers a really helpful perspective. At the top, we've got the advanced tier. Think maxed out Apple Silicon Macs or professional workstations. They're incredible, no doubt, but they are serious overkill for most home users and will massively inflate your budget. Now, the entry tier is an excellent opportunity to scout the used market. Carefully checking the cost performance of secondhand, mid-range, previous generation parts is a fantastic way to dip your toes in. But the clear winner in the source data, that balanced middle ground tier we just discussed. It hits the exact hardware configuration needed for a daily driver without wasting your money on diminishing returns.
Section 3. Parts and electricity costs. Let's shift from raw specs to the real-world economics.
Okay, here's a super surprising insight from the source data out of Taiwan. When comparing part prices and evaluating your total cost of ownership, the silent killer isn't the GPU price tag, it's the 24/7 power consumption. A machine sitting idle or running complex AI queries all day draws some serious wattage. It's basically like leaving a high-end refrigerator running at maximum cooling. Over the lifespan of your machine, those projected annual electricity costs can heavily outweigh the initial upfront market price of the hardware. It's a vital reminder that an AI server isn't just a one-time purchase, it's an ongoing utility bill.
So, to manage these running costs, we need smart, long-term money-saving strategies for 24/7 operations. First up, upcycle where you can. If you have an old case, an old power supply, or a storage drive lying around, reuse it. Second, carefully evaluate those secondhand mid-range parts we talked about earlier. The used market is packed with components that offer an unbelievable cost-performance ratio for a budget build. Finally, actively monitor your power draw. You can actually configure your system to drop the GPU into a low-power state when you aren't actively chatting with your AI. These budget-conscious strategies are exactly what make a long-term home server truly sustainable.
Section 4. Llama and software setup. moving from the physical hardware to the digital soul of the machine.
Now, you might be thinking you need to be a software engineer to run this in a real home environment, but honestly, it's beautifully simple. You really only need two main pieces of software. First is Ollama. Think of this as the back-end engine room. The installation and setup is basically just running one quick command in your system, and Ollama handles all the heavy lifting of downloading and running the AI models locally. Then, you connect it to Open Web UI, which is your dashboard. It looks and feels exactly like the cloud AI apps you're probably already used to. You spin that up, and suddenly you're chatting with your local AI through a simple browser interface. It takes the intimidation entirely out of the whole shebang.
And finally, Section 5, NAS integration and the future. Let's see how this unlocks some incredible potential.
The smartest way to approach planning your future server integration is through a phased construction path. Step 1 is just getting your basic AI assistant running, chatting with models and kind of testing the waters. Step 2, once you're comfortable, is feeding it your documents to create a personal knowledge base, literally teaching the AI about your specific world. But Step 3, that's where the major aha moment happens. You can evolve this machine into a full network-attached storage, or NAS, and a home automation hub. That single-purpose AI build eventually becomes the intelligent brain governing your entire smart home.
What really stood out to me in the source material is the incredible NAS expansion flexibility here. Because we deliberately selected a balanced hardware foundation with a standard PC motherboard, you aren't locked into a closed ecosystem, like you would be with a Mac Studio. As your family's digital footprint grows, you have a really clear path forward. You can infinitely slot in high-capacity hard drives later down the line, turning your AI machine into a massive, secure, local storage vault for all your photos, videos, and backups, all entirely managed by your own local intelligence.
So we have to ask, in an age where big tech companies are scraping every single piece of data on the internet to feed massive models in the cloud, what is the true value of completely owning your own intelligence? Building a home local AI system isn't just some fun weekend hardware project. It's a declaration of digital independence. Your data, your rules. Just think about that the next time you type a personal question into a cloud server. You have the power to secure your privacy and manage your costs with an incredibly powerful tool that answers to absolutely no one but you.